Inside the shadow of Geneva, beneath the Earth's ground, lies a shock of human ingenuity and a predicted harbinger of obliteration. The monster massive Hadron Collider. It's miles a guide of shrewd assessment, permitting researchers to research the subatomic international and inciting the revelation of the mysterious God particle, the Higgs boson. At this point, renowned physicist Brian Cox has made a chilling announcement that sent waves of marvel all through the theological network. Something concerning has been investigated, something that could have implications past our information, raising concerns that our primary goal of enlightening informational series might set us on a collision course with calamity. As we dive into this lucid conundrum, let us consider the declaration concerning the Big Hadron Collider LHC. The LHC, operated by CERN, is a 17-mile ring of superconducting magnets and the arena's most noteworthy and normally outrageous particle smasher. It represents the pinnacle of human fulfillment, recreating the situations of the universe's advent. However, should this shape plan to open new dimensions of the universe, it is able to probably cause something some distance greater big and troubling. CERN, set up in 1954, is one of the world's most famed research agencies, with 23 member states and a large array of experts. It is far a center for collaboration and improvement. The LHC is CERN's relevant venture, but it is most effective one part of an enormous array of colliders and detectors. This collider is devoted to subatomic particles, and its purpose is to explore the very material of lifestyles itself. The LHC hastens protons to almost the velocity of light, sending them on a collision path that mirrors the energy of the universe at the time of the Big Bang. The collisions produce temperatures 1,000,000 instances warmer than the middle of the sun. A big array of magnets guides the protons on their path, while state-of-the-art cooling systems maintain the magnets at temperatures chillier than space. The collider consists of 1,232 dipole magnets, which steer the beams, and 92 quadrupole magnets, which focus the beams simply before collision. Any other kind of magnet is used to press the debris collectively to growth the possibilities of collisions. The challenge of CERN is to collide debris with such precision that they meet exactly. The precision required is amazing, and the era is unrivaled. The LHC's design is a marvel of engineering. It is buried 574 toes underground, shielded from radiation. The entire collider is cooled to a temperature of 46 degrees Fahrenheit, less warm than the vacuum of space itself. This bloodless environment is vital for the superconducting magnets to feature optimally. The LHC's collisions arise at 4 regions around the ring, every housing considered one of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Every detector serves a specific purpose in reading unique elements of particle physics. Collectively, they seize unique picks of the collisions, allowing scientists to look for evidence of the elusive Higgs boson, in any other case known as the God particle, an essential piece of the universe's puzzle. Analyzing the microcosm of particles offers insights into the universe, but with every discovery comes new questions. The LHC isn't simply a sophisticated instrument. It's miles an image of human curiosity and development. It represents our quest for expertise and our desire to recognize the fundamental forces that form our universe. But, as we push the boundaries of expertise, we should additionally bear in mind the moral and existential questions that arise. What are the dangers of probing the unknown? Should our pursuit of expertise inadvertently unleash powers past our control? Inside the hallowed halls of CERN, wherein the limits of human expertise are always tested, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a prominent voice in particle physics, has recently made an announcement that has left the field each captivated and alarmed. Cox's statements resonate with a disturbing opportunity. The goal of CERN's Large Hadron Collider is to recreate a miniature model of the very occasion that gave birth to our universe. The physicist has additionally recommended that this purpose ought to lead to new discoveries, along with knowledge darkish depend, a substance that constitutes a vast part of the universe. The potential to show the proper nature of the universe is enticing, but it contains considerable risks. The idea of recreating a huge bang event isn't simply theoretical. It's miles a reality in the LHC. The temperatures, pressures, and extreme power reflect the conditions of the universe's infancy. Yet, with such strength comes massive duty, and the dangers of unintended outcomes are actual. In 1978, Russian physicist Anatoly Borsuk experienced a twist of fate that would have derailed his existence. At the same time as operating at America synchrotron, a breakdown brought about a proton beam getting into his head. Notwithstanding severe injuries, he survived and persisted his paintings. This incident highlights both the extraordinary strength and capability danger of particle accelerators. The dangers related to machines like the LHC aren't to be taken gently. The capacity for unforeseen reactions and the manipulation of fundamental forces bring considerable implications. One of the maximum regarding possibilities is the creation of microscopic black holes. These are regions of spacetime in which gravity is so extreme that now not even light can get away. The concern is that if this kind of black hole have been to form, it is able to develop and doubtlessly consume the Earth from inside. However, scientists at CERN guarantee us that any black holes created would evaporate quick and pose no risk. The concept of creating a miniature black hole has sparked full-size debate. Even as some experts agree with such a phenomenon is not likely, the very belief of it stirs unease. Expertise: the LHC's capacity to potentially create black holes entails complicated particle physics. Whilst protons collide at close to mild speeds, the energy worried can warp area-time itself, just like a trampoline bending below weight. This analogy enables to visualize the capability for developing a black hole, albeit on a microscopic scale. Inside the realm of quantum physics, wherein the nature of truth is both ordinary and profound, there exists an idea that more essential debris can be hidden within our universe. If these debris exist, the LHC's experiments ought to doubtlessly display them, developing a gravitational line that might resemble a black hole. This unsettling idea has even drawn the eye of renowned scientists just like the late Stephen Hawking. In his writings, he warned of the opportunity that the Higgs boson could behave unpredictably at extremely high strength degrees, probably main to a catastrophic vacuum decay. A catastrophic occasion that could wreck the universe. British cosmologist Sir Martin Rees has also expressed worries about the risks related to high-energy particle collisions. He has discussed the capability for vacuum instability that may cause a catastrophic event affecting the complete universe. Even as those scenarios are taken into consideration unlikely, they highlight the want for warning and cautious consideration. Vigate the profound implications of these groundbreaking experiments. Scientists at CERN have thoroughly assessed the ability dangers related to their experiments. They have carried out rigorous protection protocols and precautionary measures to mitigate any dangers. Though the pursuit of information inherently includes a few degree of uncertainty, in particular while exploring uncharted territories. The search for expertise has usually been observed through hazard. However, it's far this very pressure to push limitations that has propelled humanity ahead. The LHC stands as a testament to many years of scientific advancement and international collaboration. Underneath its staggering outside lies a realm of good-sized clinical inquiry, packed with each thrilling opportunities and ethical concerns. While the collider has already led to groundbreaking discoveries, together with the Higgs boson, it additionally raises worries approximately the potential results of its experiments. Despite giant safety measures, the possibility of unforeseen occasions, such as the advent of miniature black holes, cannot be totally ruled out. As scientists keep to explore the complexities of the LHC and the fundamental forces of the universe, it's far critical that they achieve this with a deep awareness of the capability risks and moral implications. Accomplishing open dialogue with the public and policymakers is important as we naze. Black holes are indeed possible and are well-established objects in astrophysics and cosmology. They are regions in space where gravity is so strong that nothing, not even light, can escape from them. Here's a quick overview of the different types and the current understanding of black holes. Types of black holes. 1. Stellar black holes. These form when massive stars exhaust their nuclear fuel and undergo a supernova explosion. The remaining core collapses under its own gravity, leading to the formation of a black hole. Stellar black holes typically have masses ranging from a few to several tens of solar masses. 2. Supermassive black holes. These are found at the centers of most galaxies, including our Milky Way. They have masses ranging from millions to billions of solar masses. The exact mechanism behind their formation is still a topic of research, but they may grow by accreting gas, merging with other black holes, or both. 3. Intermediate mass black holes. These black holes have masses between stellar and supermassive black holes, typically ranging from hundreds to thousands of solar masses. Evidence for their existence is less direct, and they are considered to be a missing link in our understanding of black hole formation. 4. Primordial black holes. These hypothetical black holes could have formed in the early universe due to high-density fluctuations. They could range in size from tiny, less than stellar mass, to large. While they are theoretically possible, none have been observed directly. Theoretical and observational evidence. General relativity. Albert Einstein's theory of general relativity predicts the existence of black holes as a consequence of its equations. The theory describes how massive objects warp spacetime, leading to the formation of black holes. Observational evidence. There is substantial indirect evidence for black holes. For example, observations of the orbits of stars around invisible objects and the radiation emitted by matter falling into black holes support their existence. The Event Horizon Telescope (HT) collaboration even captured an image of the event horizon of the supermassive black hole in the galaxy M87 in 2019. Gravitational waves. The detection of gravitational waves from colliding black holes by observatories like LIGO and Virgo has provided direct evidence of black hole mergers and the existence of black holes of varying masses. Theoretical possibilities and research. Black holes in the laboratory. While creating black holes in laboratory conditions, such as in particle accelerators like the Large Hadron Collider, is theoretically possible, any black holes produced would be extremely small and would evaporate almost instantaneously due to Hawking radiation. Miniature black holes. Theoretical models suggest that tiny black holes could have formed in the early universe or might be created in high-energy experiments. These would be much smaller than stellar black holes and would evaporate quickly due to Hawking radiation. Summary. Black holes are not just theoretical constructs. They are real objects with significant observational and theoretical support. They play a crucial role in our understanding of the universe, influencing galaxy formation, stellar evolution, and fundamental physics. Ongoing research continues to refine our understanding of these fascinating cosmic entities.